Hello, can everyone hear me? I'm going to be learning C++ again. Let me just change to full screen. Okay, sorry. Yeah, so last stream I completed chapter 20. So I learned about lambda captures. My main focus was on these 4 chapters. And this stream I'm going to be learning about overloading, operator overloading. I don't know how much I will finish, but I'm expecting maybe half of it, like 7 chapters maybe. We will see. Okay, wait, hold on. Let me just check a few things and I will change back to full screen. Okay. Introduction to operator overloading. In lesson 11.1, you learn about function overloading, which provides a mechanism to create and resolve function calls to multiple functions with the same name, so long as each function has a unique function prototype. This allows you to create variations of a function to work with different data types without having to think up a unique name for each variant. In C++, operators are implemented as functions, but by using function overloading on the operator functions, you can define your own versions of the operators that work with different data types. Using function overloading to overload operators is called operator overloading. So operators as functions. Consider the following example. Maybe x is 2, y is 3, and then x plus y. The compiler comes up with a built-in version of the plus operator for integer operands. This function adds integers x and y together and returns an integer value. When you see an expression x plus y, you can translate this in your head uh, to the function called operator plus x and y, while operator plus is the name of the function, where operator plus is the name of the function. Now consider this similar snippet. The compiler also comes up with a built-in version of a plus operator for double operands. Expression w plus z becomes function called operator plus wz, and function overloading is used to determine that the compiler should be calling the double version of this function instead of the integer version. Now consider what happens when you try to add two objects of a program-defined class. The intuitive expected result is that the string hello world would be printed on the screen. However, because my string is a program defined type, the compiler does not have a built-in version of the plus operator that it can use for my string operands. So in this case, it will give us an error. In order to make it work like we want, we will need to write an overloaded function to tell the compiler how the plus operator should work with two operands of type myString. We will look at how to do this in the next lesson. When evaluating an expression containing an operator, the compiler uses the following rules. If all of the operands are fundamental data types, the compiler will call a built-in routine if one exists. If one does not exist, the compiler will produce an error. If any of the operands are program-defined types, the compiler will use the function overload resolution algorithm to see if it can find an overloaded operator that is an unambiguous best match. This may involve implicitly converting one or more operands to match the parameter types of an overloaded operator. It may also involve implicitly converting program-defined types into fundamental types so it can match the built-in operator. If no match can be found, the compiler will error. What are the limitations on operator overloading? First, almost any existing operator in C++ can be overloaded. The exceptions are conditional, size of, scope, member selection, pointer member selection, type ID, and casting operator. Wait, what is type ID? I forgot. Second, you can only overload the operators that exist. You cannot create new operators or rename existing operators. Third, at least one of the operands in an overloaded operator must be a user-defined type. This means you could overload plus int myString but not plus int double. Okay. Because standard library classes are considered to be user defined, this means you can define double std string. However, it is not a good idea because a future language standard could define this overload, which could break any programs that used this overload. Thus, a best practice is that your overloaded operator should operate on at least one program defined type. This guarantees that a future language standard won't potentially break your program. Fourth, it is not possible to change the number of operands an operator supports. Finally, all operators keep their default precedence and associativity, and this cannot be changed. Some new programmers attempt to overload bitwise XOR to do exponentiation. However, in C++, operator, I don't know what you call this, has a lower precedence level than basic arithmetic operators, which causes expressions to evaluate incorrectly. You need to explicitly parenthesize the exponent part every time you use it for this to work properly, which isn't intuitive and is potentially error prone. Because of this precedence issue, it's generally a good idea to use operators only in an analogous way to their original intent. When overloading operators, are supposed to keep the functions of the operators as close as the original intent of the operators as possible. Furthermore, because operators don't have descriptive name, it's not always clear what they are intended to do. For example, operator plus might be a reasonable choice for a string class to do concatenation of strings, but what about operator minus? What would you expect that to do? It's unclear. If the meaning of the overloaded operator is not clear or intuitive, use a named function instead. Finally, overloaded operators should return values in a way that is consistent with the original operators. Operators that do not modify their operands should generally return results by value. Operators that modify the leftmost operand should generally return the leftmost operand by reference. Operators that do not modify their operands should generally return results by value. Okay, within those confines, you should find plenty of useful functionality to overload your custom classes. You can overload the plus operator to concatenate your program defined string class or add two fraction class objects together. You can overload this operator to make it easy to print your class to the screen or a file. Okay, it means it's open chapter 3 as well. Overloading the arithmetic operators using friend function. Some of the most commonly used operators in C++ are the arithmetic operators, that is plus, minus, multiplication, division. Note that all of the arithmetic operators are binary operators. It turns out that there are three different ways to overload operators: the member function way, the friend function way, and the normal function way. In this lesson, we will cover the friend function way. Next lesson, we will discuss the normal function way. In a later lesson, we will cover the member function way. Consider the following class. So cents, we have a private member of cents. So cents int cents. Okay, and then integer get cents. The following example shows how to overload operator plus in order to add two cents. So friend cents operator plus, the reference of this and reference of this. So return c1.m cents, c2.m cents. Cent1, cent2, centsum. Overloading the plus operator is as simple as declaring a function named operator plus, giving it two parameters of the type of the operands we want to add, picking an appropriate return type, and then writing the function. If I remember correctly, friend means that the function can be defined outside and it can access the private members, right? So friend means this function is defined outside And while being defined outside, it can access the private members, from what I remember. Okay, in the case of our sense object, implementing our operator plus function is very simple. First, the parameter types. In this version of operator plus, we are going to add two sense objects together. So our function will take two objects of type sense. Second, the return type. Our operator plus is going to return a result of type sense. So that's our return type. Finally, implementation. To add two sense objects together, we really need to add mSense member from each sense object. Because our overloaded operator function is a friend of a class, we can access mSense member of a parameter directly. Also, because mSense is an integer and C++ knows how to add integers together using a built-in version of plus operator that works with integer operand, we can simply use the plus operator to do the adding. Overloading the subtraction operator is simple as well. Friend functions can be defined inside the class. Even though friend functions are not members of the class, they can still be defined inside the class if desired. Okay. I forgot what the explicit keyword does. Overloading operators for operands of different types. Often it is the case that you want your overloaded operators to work with operands that are of different types. For example, if we have sense 4, we may want to add the integer 6 to this to produce the result sense 10. When C++ evaluates the result x plus y, x becomes the first parameter, y becomes the second parameter. When x and y have the same type, it does not matter if you add x plus y or y plus x. Either way, the same version of operator plus gets called. However, when the operand have different types, x plus y does not call the same function as y plus x. For example, sense 4 plus 6 would call sense operator plus with sense and integer, and 6 plus sense 4 would call operator plus int and sense. Consequently, whenever we overload binary operators for operands of different type, we actually need to write two functions, one for each case. Here is an example for that. So plus plus okay, they have two different functions now. Let's take a look at another example. So min max, minimum maximum, operator plus so what does plus return? Minimum is less than minimum. Wait, so int minimum, or it returns another min max type where the values of minimum and maximum are different. So 10 and 15, m final m1 plus m2 plus 5 plus 8 plus m3 plus 6. The min-max keeps track of minimum and maximum value that it has seen so far. We have overloaded the plus operator 3 times so that we can add two min-max objects together and add integer to the min-max objects. This example produces the results 3 and 16. So out of all of the integers over here, 3 is the smallest and 16 is the largest. So when you add two min-max together, min is the smallest of all four values and max is the largest of all four. All four meaning min max of this and min max of this. So 4 values in total. Implementing operators using other operators. In the above example, note that we have defined operator plus int min max by calling operator plus max min max int. This allows us to reduce the implementation of operator plus int min max to a single line, making our code easier to read. Okay, let's do the quiz. Write a class named fraction that has an integer numerator and a denominator member. Write a print function that prints out the fraction. Your code should look like this. So f1.print, f2.print, and it prints like this. Okay, I need to revise my knowledge on classes because I forgot a lot. So let's see how much I remember. Class fraction private int numerator. Is this correct? Why is private int m underscore denominator and then public fraction num1 in num2. I forgot how the construction works. Things like this. M no M numerator num1 and then M denominator num2. It's a comma, not a semicolon. Then we do this. Is that correct? That is correct. So we need to define a print function. But print is like part of the thing, right? It's a member function. It's not like outside of the class. Print std cout m numerator m denominator I have to define void. How do you cancel a build if there's a build mid process? Yep. Now we did that. Add overloaded multiplication operators to handle multiplication between a fraction and an integer and between two fractions. Use the friend function method. Between a fraction and an integer and between two fractions. So we will print, we have a friend operator multiplication fraction f1, then int num, and then f1. Wait, oops, this should be in here. Fraction f2. So let's see, is this correct? Is this how they did it? Friend operator plus. Oh yeah, and the return type is fraction. So uh, okay, let's define it. So take this over here. Let's see. F dot m numerator we return f dot m numerator f1 frac times it by f2 dot m numerator. N dot m underscore denominator. This is a fraction. Let's see. And we also have to define this one. I think what I can do is int num fraction f. What I can do is return fraction f dot m numerator times num f dot m denominator times num. So f3 is f1 times f2, and then print f3 f2 times, then print f4 as well. Now let's see. Let's see. So f1 times f2 is 1 over 8, 2 over 4. Right. This works. What is explicit? I keep forgetting this. So what do they do? Oh no, this is the previous solution. Let's see if their test cases work. We don't want to pass by value because copying is slow. Can't and shouldn't pass by non-constant reference because then our function wouldn't work with our values. Okay, I need to do the other one as well. So yep, this and this. And since we aren't modifying, we should put this as const. We should put this as a reference. And we should put this as const. We should put this as reference. Should put this as const and reference. Let's see if it works. Two over 5, 3 over 8, 6 over 40, 4 over 5, 8 over 16, 6 over 24. So what happened here? Numerator denominator. Oh, no, wait. It's only the numerator that... so we can define this as f times num, like that. Let's say 2 over 5, 3 over 8, 6 over 40, 4 over 5, 6 over 8, 6 over 24. Why does the program continue to work correctly if we make the constructor non-explicit and remove operators for integer multiplication from the previous solution? Remove explicit from constructor. We can remove these operators and the program continues to work. When we multiply a fraction with an integer, for example this, the non-explicit fraction int 8 constructor will be used to construct a new fraction from 2. Before I delve even further, I want to get a reminder on what explicit meant. So 5, 6. Maybe it's this chapter. Class 4. Private members, access function, a constructor. We can use the implicit keyword to tell the compiler that the constructor should not be used as a converting constructor. Such a constructor cannot be used to do a copy initialization or copy rest initialization, nor can it be used to do implicit conversions. Make any constructor that accepts a single argument explicit by default. If an implicit conversion between types is both semantically equivalent and perform it, you can consider making constructor non-explicit. Where do they mention this? Class initialization, maybe? In the summary, they seem to mention it as a last topic. So I think it's much later. This 14.16 explicit keyword. In the above example, the compiler will find a function that lets its value int that lets it convert int value 5 into foo object. That object is the foo int constructor. So for int, we are doing print for 5. We are supplying an int argument, but it accepts 4. So the compiler does print 4 and then it takes the 5, convert it to 4. We are providing an int value and getting 4 object in return. In the context of a function call, we are trying to solve the same problem. We are providing an the full int constructor was designed for exactly that. So in this case, when print for 5 is called, the parameter f is copy initialized using full int constructor with 5 as the argument. A constructor that can be used to perform implicit conversion is called converting constructor. By default, all constructors are converting constructors. Only user-defined conversion may be applied. Only one user-defined conversion may be applied. Now, consider the following example. So string view name. This version we have swapped a foo class for an employee class. Print employee has employee parameter and we are passing in a C style string literal. Okay, they're talking about this. And we have a converting constructor employee string view. You might be surprised that this version doesn't compile. The reason is simple. Only one user-defined conversion may be applied to perform an implicit conversion. This example requires 2. First, a C-style string literal has to be converted to string view. And then from string view, it has to be converted to employee. There are 2 ways to make this example work using name std literal. So we are passing in a string view and then employee Joe. Consider the following program. When we call print 5, the $int converting constructor will be used to convert 5 into a dollars object. Thus this print $5. Although this may have been the caller's intent, it's hard to tell because the caller did not provide any indication that this is what they actually wanted. It's entirely possible that the caller assumed this would print 5 and did not expect the compiler to silently implicitly convert our int value to the dollar object so that it could satisfy this function call. It would be better if our print dollars function could only be called with a dollars object, not any value that can be implicitly converted into dollars. To address such issues, we use the explicit keyword to tell the compiler that a constructor should not be used as a converting constructor. So explicit $5. So this will cause a compilation error. For constructor with separate declaration inside the class and definition, the explicit keyword is used only on the declaration. Assume $int is explicit. So $d15 is okay, $d25 is okay. An explicit constructor can still be used for direct and indirect list initialization. Okay. But it can't be used here. We have to do this instead. And static cast will work. Okay, I guess I get the idea. So we are doing it explicit. If we do this explicit, it will only, we have to do fractures int. Otherwise it doesn't work. What was the question they asked? Why does the program continue to work correctly if you make the constructor non-explicit and remove the operators from the integer multiplication from the previous solution? So it's implicit now, right now, and we remove these 2, the integer ones, and then it still continues to work. We still have this. When we multiply a fraction with an integer, for example 2 times f2, the non-explicit fraction int in constructor will be used to construct a new fraction from 2. This new fraction is then multiplied by f2 using fraction times fraction operator. Because this requires converting 2 to a fraction that's slightly slower than the implementation with overloaded operators for integer multiplication. If we make the reference parameters with operator times fraction non-constant, the following line from the main function no longer works. Why? We make the reference parameter non-constant, the following line from the main function no longer works. Okay, so they're talking about removing constant from here. What line doesn't work? This doesn't work anymore. So fraction times a fraction. Wait, really? Hold on, let me see. If I remove this, this, and this, if I run, where is the error? 44? Line 44. No operator found which takes the left hand operator of type fraction. Left hand operand of type fraction. Now let me see. Yeah, multiplying temporary fraction objects, but non-constant references cannot bind to temporaries. Hold on. Yeah, constant. Oh, this here is a temporary object. Okay, so multiplying it with a temporary object won't work with a non-constant. I can't remember exactly why this is the case. Okay, something came up. I will have to end the stream here, but like after a few minutes, I might restart the stream. Okay, I will just end the stream here and then I'll come back. Something came up, sorry. Okay. Okay, so see you soon, I guess.